Okay, welcome to our part 2 of the basic Python programming. If you're following along in the study guide or the user guide, we're on page 4, and we've just in the previous video shown how to create a new file and to save that file with the extension .py. So now we're actually going to write some Python code and output the results of that. So what I'm going to do is I'm going to come back to my my Spider software here with this file that we created, labpython1.py, and this is where I'm going to actually start typing the code. So the first command I'm going to type is import something called numpy as np. Okay. So import numpy as np. So import, you use this command always at the very top of your file. The very first thing you add to your Python file are any packages you need to import, okay? So import always goes up the top. So I'm importing this file or this package called numpy, which is all the mathematics actually in Python. So all the simple to complicated mathematics is stored in this numpy. It's a very common package that you'll find lots of scientists using in different areas. Okay, so I'm importing numpy, but I'm importing it as np. And so np is basically just a shortcut for numpy, okay? So instead of going around writing numpy everywhere, I'm just going to have to write np. So it's just a shortcut, and you'll see how it's used a little bit, maybe in the next lab. Okay, so now I just want to do some basic things. So I'm just going to I'm going to create a new variable called a, or a new structure called a, and I'm just going to say a is equal to 1 plus 2. Okay, I'm going to create a new variable called b, and I'm going to say b is equal to 4 minus 3, and similarly c is equal to 3 times 3. So this star thing here is multiplication, so this is 3 multiplied by 3, and d is equal to a 8 divided by 2. Okay, so these basic mathematics operations, actually we don't need numpy for. We'll use numpy later, but these basic mathematical operations work as you might expect. And I can just give a the value of 1 plus 2, so obviously a is equal to 3. Let's try that out, and we'll try that out soon. And of course, once I've given a this value of 1 plus 2 equals 3, and similarly b, c, and d, I can actually do useful things with them. So I might say e, this new variable e, is equal to, let's say, a multiplied by d. So now a multiplied by d, well, a is 1 plus 2, so a is 3. D is 8 divided by 2, so D is 4. So 3 multiplied by 4, this should be 12. So the value of E should be 12 here. And before we check that though, I also want to introduce one more command, and that's the print command. Okay, so we use the print command whenever we want a message to be displayed on screen. So print, and then some regular curved brackets, and two, I don't know what you call these, quotation marks, and inside these quotation marks we can type whatever we want. And usually you try and spell things properly. I hope the All Blacks win the next. I do, by the way. Okay, and so what I'm going to do is, now that I've made changes to my file, I'm going to save it. And so I can do that, at least in Windows, using the Control and the S, Control S to save, or I can go up here and click Save. Okay, I've already pressed Control S, so this icon is blanked out. But you can click this icon to save it. Okay, to run a program that we've just written in Python within the Spider environment, well, all we have to do is press this green triangle here. This is Run File. So we can either press this green triangle or press the F5 button to run. I'm just going to click the green triangle. And I might just actually clear everything in this console over here and then run that again. So, okay, all this stuff in green here, all this stuff up here is just some file preamble. It doesn't actually mean it's not part of your code per se that you've written. But you can see underneath that, whatever we want. I hope the All Blacks win the next World Cup. So this output that we've printed here has been printed on screen. So that's good. We know that print works. Unfortunately, it hasn't actually shown us the values of A, B, C, D, and E, right? So in the background, it has actually calculated these values, but it hasn't shown us on screen. So we want to be able to add that to our code. Okay, and the way we do that is, again, using the print command. So anything that we want to be displayed on screen is going to be done using the print command. Okay, so what I'm going to do is I'm going to write print, and inside these two quotation marks, A equals, okay, so if I save and run that now, I have this extra bit here, A equals, still doesn't tell me what A is equal to, okay, coming back over here, A equals, now outside of the quotation marks, I'm going to type plus str A. Okay, so what this does is it prints on screen this text, A equals, and then it takes the value of A, which you calculated up here, so now the variable A, and adds it to the string, adds it as a string. So this turns this numerical value of 1 plus 2 equals 3 into a string. Okay, so now watch what happens when I save and run my code. Whatever we want, I hope the All Blacks win the next World Cup, good. A equals 3 as we expected. So I can do that now for all my variables. Let's go B, let's go C, let's go, I'm just copying and pasting here in case you were wondering. And let's go E, and let's just make sure that it's calculating these numbers correctly, okay. So I just saved it, I'm gonna run it. So A equals 3, okay, good. B equals 4 minus 3 is 1, perfect. C equals 3 times 3 is 9, perfect. D equals 8 divided by 2, which is 4, perfect. And E equals A times D, so 3 times 4 is 12. So you can see here that the Python code that we've written is actually calculating everything correctly, so we're happy. Sometimes, though, you won't want to do just basic, simple operations like addition, subtraction, multiplication, and division. Sometimes you want to do slightly more complicated things like trigonometric functions. Evaluate, for example, if, okay, f equals sine of 0. So we'll say f is equal to sine of 0, and we'll also print the value of f onto the screen, okay? So of course, if you know your mathematics, you know that the sine of 0 is itself 0. So if I run this, I should get, a lot of errors, okay? So the name sin for sine is not defined. Okay, so this is why we had to import this library called NumPy, okay? So Python itself doesn't know what trigonometric functions are. So I'm just going to clear my console here to make it all pretty again. And now instead of f is equal to sine of 0, I'm going to write np for numpy dot sine 0. Okay, so numpy np dot sine of 0. If I save and then I run that, now I actually get f is equal to 0 as we expect. Okay. So, well, let's try that one more time, but instead of instead of sine, let's try cosine of 0. So, and let's call that g. So for those people following along at home, the cosine of 0 is equal to 1. So let's just output that value as well, save and play. G equals cosine of 0 equals 1. Perfect. So this seems to be working properly. So the key point is here, for basic mathematics, addition, subtraction, multiplication, and division, Python will do that automatically. But for things that are slightly more complicated, like trigonometric functions, sine, cosine, tangent, things like that, we have to use this NumPy thing that we imported, this NumPy library. So np.sine of 0, np.cosine of 0. So this is we're going to use NumPy a lot in this class, okay, in following videos. The last thing to note is that the values that we're evaluating here, sine of 0, cosine of 0, these values are in radians and not degrees, okay? So if you want to use degrees, which we might do if we're working with, let's say, latitudes and longitudes, we first are going to have to convert our degrees into radians to be able to use these trigonometric functions. Okay, and this is going to be the next class. Okay, see you there.